Hey guys, this is the video for similarity in right triangles for geometry. So it's based on a fact, fairly simple fact. And the fact is that if the altitude is drawn to the hypotenuse of a right triangle, then two smaller right triangles are created. Each of which is similar to the whole right triangle. Okay? So if the altitude is drawn to the hypotenuse of a right triangle, then two smaller right triangles are created, each of which is similar to the original triangle. So if I draw a picture of this, I'm going to draw a picture of a right triangle sitting on its hypotenuse like this. And what this is saying is if I draw the altitude to the hypotenuse, use a different color, like this, altitude drawn to the hypotenuse. Remember, an altitude is a line segment that goes from a vertex to the opposite side perpendicularly. So if the altitude is drawn to the hypotenuse of this right triangle, then you have three right triangles. You have the one on the left, the little tiny one, the one on the right, and then the whole big triangle. Okay, that's the bottom line. And so these types of problems, the way they'll look is they'll give you certain pieces of the triangle lengths and ask you to find missing lengths. Okay, now let me show you how to go about this. In order to do this, let me redraw the picture, okay? So if I have a picture like this, a right triangle sitting on its hypotenuse, and then the altitude drawn to the hypotenuse, so like this, there's the picture, all right? I actually have a little model made out of paper like this. So this is kind of the same situation, right? We have the altitude drawn to the hypotenuse of a right triangle, right? And we have three triangles created. So what I've actually done is I've made smaller triangles that fit perfectly into those spots. So let me do that. Let me put them in those spots. Okay. And what you see is that the three triangles, although they're similar, they're not exactly situated the same way, right? Like if you look at the whole big right triangle, it's sitting on its hypotenuse. If you look at the small right triangle right here, it's sitting on its short leg. And if you look at the medium-sized right triangle over here, the green one, it's sitting on its long leg. So what you have to do in order to figure out which side goes with which is redraw the picture so that all three triangles are situated the same way. So if I redraw this, let me move this down a little bit. Let's suppose I redraw each of the three triangles in this picture, small, medium, and large. So the small one, I'm going to draw it actually so it's sitting on its long leg. And a medium one, I'm going to draw so that it's sitting on its long leg. And the large one, I'm going to draw so that it's sitting on its long leg. So I have three triangles. They're all similar to each other, but now they're situated the same way, right? Well, what did I have to do to get them to be situated the correct way? Well, let's look at the smallest one first of all. If I look at the smallest triangle, okay, this little blue triangle right here, and I want it to be sitting on its long leg. Right now it's sitting this way, right? If I want it to be sitting on its long leg, what do I have to do? I have to take that triangle and rotate it 90 degrees clockwise, right? Think about that. It's sitting like this. To get it situated on its long leg, I rotated it 90 degrees clockwise. Okay, so that's what I have to do to this small one. You rotate 90 degrees clockwise. Okay, what did I have to do to the middle sized triangle, this green triangle? Well, right now it's sitting like this, right? That's how it's sitting. If I want it to be sitting on its long leg, it already is, right? It's already sitting on its long leg. So this one I had to do nothing to it, right? It just had to just move it, right? So this is already good. And if I look at the largest triangle, this red triangle, what do I have to do to that? Well, right now it's situated like this. If I want it to be sitting on its long leg, well, if I just rotate it around, it's facing the wrong direction, right? So if I take the original triangle, what I really have to do is I have to like flip it over like that. Then it's situated the right way, right? It was originally situated like this, and I have to flip it over so it's situated like that. Okay, I have to like reflect it over. Think of it as like a flip over, reflection. Okay, so this is a reflection, a horizontal reflection, or a horizontal flip. Okay, so let's just review that. So I got the three triangles here, right? And think about how they're situated originally, right? And you can make these for yourself if you want to use in quizzes or whatever. So the smallest triangle needed to be rotated 90 degrees so that it's situated the right way. The middle triangle is all good. It's already situated the correct way. And the largest triangle, you have to take it and flip it over horizontally. Now they're all situated the same way. That's the key to these problems is understanding how they relate to one another and how you can change them so that they're all situated the same way. Okay, so let's try a problem. So if I look at a typical problem in Delta Math or whatever, okay, the picture's gonna look like this. We're gonna have a right triangle with the altitude drawn to the hypotenuse like that. And they're going to give us certain lengths. Like, for example, maybe they'll say, this is 3, this is 12, and this is x. Find x. Okay, so all you're going to do in a problem like this is just redraw the three triangles so that they're all situated the same way. Like if I take the smallest triangle and I rotate it 90 degrees, right? If this is the 3, but I rotate it 90 degrees, this is now going to be the 3. And if this is x, this is now going to be x. Right? This is that same small triangle, just situated a different way, right? I just rotated it. That's all I did. For the middle sized triangle, if I redraw it, I don't have to do anything, right? It's already situated the correct way. This is x and this is 12. And if I look at the largest triangle, in order to get it situated the same way, like this on its long leg, I have to flip it horizontally, right? So if I flip this horizontally, this hypotenuse, which has a length of 15 total, is going to be here, 15. Right? I don't really know any other lengths of the sides of this triangle. I only know the length of its hypotenuse. So after you've redrawn the three triangles so that they're all situated the same way, the next thing you need to do is figure out which two triangles do I have matching information for so I could set up a proportion and solve. And you can see it's these two. These are the two that I have matching information for, right? I have the short leg and the long leg of the smallest triangle, and I have the short leg and the long leg of the middle-sized triangle. So all I need to do now is just set up a proportion. I could say 3 is to x as x is to 12. And then just cross multiply and solve. So x squared would be 36 and x would be 6. Boom. Simple. right? But the key is to make sure you draw the 3 individual triangles and make sure you draw them and label them correctly, because then you can determine which 2 triangles you're going to compare in a proportion. Even though they're all similar, they don't all have the same information, so you can't necessarily compare them. All right, let's try another one. Same picture, a right triangle with the altitude drawn to the hypotenuse like this. Okay, this time, let's say this is 8, and this is 2, and this is x. The whole hypotenuse is what we're trying to find. Okay, same type of problem. The first thing I'm going to do is I'm going to redraw 3 triangles. I got small, medium, and large. The smallest triangle, if I rotate it 90 degrees, this is going to be 2 and 8, right? The 8 is the hypotenuse, so it's going to be still in the hypotenuse spot. The middle triangle, I don't really know any lengths of the sides of the middle triangle. I mean, I could say that this side right here is really like x minus 2. That's definitely true. So this would be like x minus 2. They didn't give us that explicitly, but we can actually just deduce that. If the whole thing is x and that part of it's 2, then that part has to be x minus 2. And then the whole triangle, if I flip it over, right, I flip it over horizontally, the short leg is 8, that's here, and the hypotenuse is x. So you can see which 2 triangles we're going to compare. In this case, the smallest and the largest. So the proportion here would be 2 is to 8 as 8 is to x. So 2x equals 64 and x equals 32 when I cross multiply. Okay. Let's just do a couple more problems. If I have a right triangle with the altitude drawn to the hypotenuse, this time let's say that this is x and 4 and 6. Same thing. I'm going to redraw the 3 triangles. The smallest triangle, I know that its short leg is x. The middle triangle, whoa, that's ugly. I know that this is 4 and 6. And the whole big triangle, if I flip it horizontally, this is 6 and this is x plus 4. So which 2 triangles am I going to use? It's these 2, right? Those are the 2 I'm going to use because those are the 2 that have matching information. So I have 6 is to x plus 4 as 4 is to 6 and cross multiply. I get 4x plus 16 equals 36. Don't forget when you multiply this way, you have to distribute. So 4x equals 20 and x equals 5. Okay, that's all there is to these problems. Let me know if you need any help with anything, and I'll see you soon. All right, thanks, guys.